So in 3.11,
this is
we're
our
looking
last video
at
for
writing
chapter
and
3,
balancing
and it's
chemical
covering
equations.
sections 3.11
So it's important to know the different parts of a chemical
3.12.
equation. There we go. The chemicals that are listed on the left-hand side are called the reactants. The chemicals on the right-hand side are called the products. In order to make a balanced chemical equation, which we will practice here in a couple slides, we use coefficients in front of the compound. So this 2 in the front here tells me that I have 2 magnesium oxides, which means there's 2 magnesiums and 2 oxygens. These numbers you can change in order to balance the chemical equation. Subscripts belong to that formula though, and you cannot change those. So we have to have the same number of atoms on each side. For example, here's 2 oxygens. Because of this 2 in front, there's 2 oxygens. There's 2 magnesiums, and there's 2 magnesiums. So this is a balanced chemical equation. A couple other things that chemical equations include: we put the states after each chemical. So a G for gas, L for liquid, S for solid, and the one that we haven't talked about is AQ. AQ stands for aqueous, which means it's been dissolved in water. Not an official state of matter, but a very common way to react chemicals. Above the arrow, so the arrow that shows the transition from reactants to products, sometimes we use symbols or words to talk about how the reaction occurred. A little triangle means that we added heat. These two symbols together, so this is an H and a nu, so this is Planck's constant and the symbol for frequency. This means that we used light. Shock means that we use some sort of mechanical, so maybe a vibration. And then ELEC, or short for electrical, means we added an electrical pulse. These last two are not very common for us in higher level chemistry classes. We see these two on the lines occasionally. So we're going to practice one. Write the balanced chemical equation for the reaction of aqueous sodium hydroxide with aqueous iron 3 chloride to form solid iron 3 hydroxide and aqueous potassium chloride. So this is a very heavy question. It's asking a lot, and we have to know how to write a chemical formula from a name, as well as write the equation and balance it. So we pick out the pieces. It's telling us that we have potassium hydroxide and iron 3 chloride as our reactants. And we have to use kind of the words in the reaction to say this. It's the reaction of this with this. So that tells us that we're putting those two together and then to form, so that means that the rest of the stuff are the products. The iron 3 hydroxide and potassium chloride then are the products. So for potassium hydroxide, we know potassium is a K+, we know hydroxide is an OH-. We will talk about this in class, so if you're watching these videos before we've done the lecture, the in-class lecture of Chapter 3 will cover naming. We balance their charges when we put them together, so it's a 1-to-1, 1 plus and 1 minus, so we get KOH. Iron 3 chloride, iron is a 3+. We know this because that 3 tells us it's a 3+. Chloride is a 1-, so 3+ and 1-. We do our cross rule, so we end up with FeCl3. So we have 3 pluses, we have 3 minuses. Those are our reactants. On the product side, we have iron 3 hydroxide. So again, Fe3+, OH-, we get them together in a 1-to-3 ratio. And potassium chloride, K+, Cl-, and a 1-to-1 ratio because we have a 1+ and a 1- charge. Those are our products. So we can write out our equation including the states. We know that these are aqueous and solid because it tells us in the equation, aqueous, aqueous, solid, aqueous. It's not anything we had to guess, we just had to use all the information. The last thing is that it does say it needs to be a balanced chemical equation. So the way that I do this is I start by listing all of the elements that we're using. K, OH, iron, and chlorine. Now I keep the OH together because it's written as hydroxide on each side of the equation. You can write them out separately, it will work just the same. If you do it this way, I think it makes it a little bit easier though. Then I fill in how many of each elements are on each side. 1 potassium, 1 potassium. 1 hydroxide, 3 hydroxides. 1 iron, 1 iron, 3 chlorines, 1 chlorine. So when we look at what's balanced, potassium is balanced and iron is balanced, the hydroxide is not and the chlorine is not. So in order to get the hydroxide balanced, we have to change it. We have 3 over here, but only 1 over here. So I can put a 3 right here, and now when I change my numbers, I now have 3 potassiums and 3 hydroxides. Now this solved one problem but created a new one. Our hydroxides are now balanced, but the potassiums aren't. But that's okay, we're not done yet. So then what's unbalanced are the potassiums and the chlorines, but we can solve that with one thing. If we put a 3 right here, now I have 3 potassiums and 3 chlorines, and I have a balanced chemical equation. So we have to have the same number on each side. The purpose of this is the law of conservation of mass. We can't magically lose potassiums or magically gain hydroxides. The amount has to stay constant. The last section in this chapter is about organic compounds. Now the word organic does definitely not have the same meaning outside of our classroom as it does inside of our classroom. Historically, organic compounds were generally things that were living. That is not the definition. Organic really just means that it's carbon-based. So anything that contains carbon as its main element is an organic compound. It almost always contains hydrogen, and then there's other elements that pop up here and there. But really, organic chemistry just means carbon chemistry. Organic chemistry is divided up into functional groups or areas of molecules, and so we're looking at a couple of them here. You just need to be able to recognize these. So we have 4. A hydrocarbon is really any molecule that's just hydrogen and carbon, so hydrocarbon. An alcohol contains this small portion right here. So it has an oxygen bonded to a hydrogen. This is an alcohol group. There's a lot of different types of alcohols, and this is what makes it an alcohol. A carboxylic acid contains a COOH group, sometimes written as CO2H, just combining the oxygens. But really what it is a carbon that's double bonded to one oxygen, single bonded to another oxygen, and then has a hydrogen. Now this one has a hydrogen over here, this one has a carbon with some hydrogens. This portion doesn't matter. This could be a very long extra chain, it could be other stuff, or it could be very short. As long as it contains this part, it is a carboxylic acid. And then the last one we're going to look at is an amine. Amine just means that it contains nitrogen. So this might be a word that you've heard in biology or will hear in biology in the future, but it just means a nitrogen-containing compound. So nitrogen likes to form 3 bonds. So in this one it has 2 carbons on one side, 1 carbon, and then a hydrogen. But those can vary. So if you're shown a picture of a molecule, you should be able to recognize what category it fits into. Alright, that is it for this video.